So at this moment, I'm gonna stop operators, and we come back to operators. There is another operator that we use a lot in programming, which is called ternary operators. It's a very interesting operator, but I'm gonna focus on that a bit later when it comes to the context, so you are not overwhelmed with operators all at once. Then what else is here is basically, then we spoke about the variable types, and okay, physical connections, and I'm going to start talking about conditions. We talked about conditions last time, so you're familiar with if conditions. You know that we could use if else conditions. Something that was unfinished in our previous session, in our previous part of session 2, was this thing about the if conditions that I wanted to explain. So you have to consider something, and you have to know that specifically if you have experience with programming languages like Python. In Python, when you say if and you have an indentation, basically, if I remember correctly, you continue, add lines, and these lines are all considered the block of code of this if code block, if I remember correctly. I think Anil has experience, so this can be misleading for people with experience with other programming languages. What's going on in C# is that in C#, if you have only one line of code after your if statement, or also after your for statement, or any of these specific statements, you can forget about the curly braces and just write your line of code, your expression line of code, immediately after or on the same line. So basically, what I can do is I can have this back there on the same line, also back here on the same line. So you see, this can make it actually make the code much more concise for something which is very simple, and you don't have to write a lot of code. This could be also one line of code. This is also possible. Everything is the same. It interprets very easily. Sometimes we do that for our readability to make it, to write it in several lines. But what if I have more expressions to write in one or in all of these sort of lines of code? And what we should know also in C#, those indentations are called, at some places, are called white spaces. We have white spaces and implicit explicit spaces. So those are white spaces. So if I run the code, nothing changes. But this is not the case in Python. In Python, if you don't have that indentation, then you're missing something, because that's how Python understands the situation. So this is important. You have to know how to deal with this whole writing syntax. But if you have more than one line of code, you have to define the block of code, the code scope. So how do you do that? You add these curly braces, and then you have this line of code, the commands inside those curly braces. And this could be 2 lines, 3 lines, whatever lines. So if the else is only one line, you can exclude curly braces for else. But if else is also more than one line of code, you have to add the curly braces here as well, and then add those lines of code here as well. Okay, so if I run that, you see 3 times ciao, because I have it 3 times in a row. Okay, so if it's just one command on the same line, it doesn't need. No, if it's just one command, one line of code, you don't need the curly braces. No, but if it's more than one line of code, you need. And don't get it wrong. So basically, this is again 2 lines of code here. I mean, this is 3 lines of code here. Okay, because you have 3 times semicolon. Okay, this is not one line of code, because I've received this complaint from someone that, hey, you said if I write one line of code, it's fine. So I wrote one line of code, but it doesn't work and it gives me an error. But why does it work? That's weird. Actually, it shouldn't run. Maybe it's something new in C# 12. Okay, this is something I should check. I should check it, and let's check it here. Yeah, exactly. It shouldn't run that. Let me check if it's a. What is the reason for that? Yeah, also in C#. This is something. So I can copy this code and paste it here. Okay. Okay, this is funny. Ah, you know what happens? I tell you what happens. I tell you what happens. So I ask you a question. Now we have, no, it's very simple. It's something very simple. I was also confused for a second, but now I tell you what happens here. We can interpret it with a very specific, with a very small trick. So here we never go to this condition, okay? Because both of them are true. Okay, so if one is false, we would go to here. So I ask you a question. If I run this code, what would be the answer inside the terminal? Would it be 3 hellos, or would it be 3 Charles, or what? It would be 3 hellos and 2 Charles. You see? Do you see why now? Yes, it's fine that you're confused. I was also confused. The point is, it doesn't give you error because it doesn't see curly braces. It considers this one line of code for the else. The rest, it doesn't matter where it is. It's the rest of the code. So it always runs this part, no matter if you go to else or not. Okay? Yeah, it's out. It's out. So we see the first so it's like if it's like FF, or it's like, I don't know, HH, whatever. So it doesn't relate to the child. It's like we see that anyway. That's why we didn't receive an error. But if you have that here after the else, if you remove those curly braces here, we're gonna receive an error, because now it says like, hey, you have 3 lines of code here, which doesn't work. And if you basically copy that again up there, it's still, there is an error, because this is not, yeah. So, and actually you see, that was something that would have been something that you wouldn't receive an error. And this was an error that could become a pain for debugging the program if you were not. Yeah, exactly. So always remember the curly braces to use. And uh, uh, we can actually, I'm sure ChatGPT can recognize the error of this. But the point is, like, if you write a lot of lines of code and the condition of else was not happening while you are testing the code, and suddenly it happens when the code is too big, the question is that, for example, imagine you're dealing with some geometry. It's not like this that you see everything obviously there. And you don't see, for example, that like the normal of that surface, which you thought it changed, was not changed because your code was like that. And you don't see any error. but you try and you see, okay, the result that I want is not there. And I don't understand why, but it's something that it gives me a geometry, but it is not the geometry that I want. And sometimes these sort of errors can take weeks, months, forever to yeah, exactly. Yeah, yeah, exactly. So yeah, this was an interesting, like unpredicted mistake. That was nice. Okay. So so you got it too also, Kesra, right? You realize why that was okay. Perfect. So let's go back here and so just remember about the blocks of code. And here there is also another situation that I want to already use this context to explain. And that situation is the scope of variables and scopes of code. So what does it mean when we use this word scope? So the point is, like, you have scopes of code and you can relate it easily with these curly braces, okay? So these are regions of code that is seeable for variables and everything. And when you have, you always have scopes within scopes and within scopes and like several scopes inside each other. So it's possible that you have, like here, let's look at here. So we basically have a public class inside this scope of yellow curly braces. Then we have a scope inside that, which is defined by these like pink curly braces. Okay, so why is it important to look at these scopes? Because we always need to know that we can see the contents of each scope based on their access to each other. So if I define something inside this pink scope, like if I define int a equals 10 here, then this integer value is defined inside this scope. So if I have whatever another scope here, and then I want to use int a, and I want to say, for example, console dot write line. This code is not legit. I'm just like trying to show you. This doesn't anyway work. Dot write line a, it tells me like invalid token. A is not defined here. I don't have a here because this a is defined up there. So if I copy that there, then it works. It prints console, okay? And I cannot just have a random curly braces here. Like this could be a method or something here, but the point is, like, you have to know always, if I want, and then if I have several scopes, like, well, I don't know, scope A here, and then another scope here, and then another scope here, for whatever reason, imagine these are different methods or something. Then, so this is one scope, this is another scope, and this is another scope. So I would call it scope A, and then scope B, and then scope C. Okay. So if I have these three scopes here, and I want to do something there, then, and I want to have a variable that works everywhere here, I cannot define that variable inside one of the scopes on the same hierarchy. So another word that we are talking about is the hierarchy of the scopes. I need to define this variable somewhere above the hierarchy. So if I define this int a here up there, or it doesn't matter, down there here, it is still in the outer hierarchy. So all of these scopes, they can access to this a. okay? And if I go again one hierarchy above, all of the lower hierarchies can access that. So why this is important? Because if you are defining something, this is again another like mistake that I see some people do. So for example, like they have an if here, and they say if BLN A and BLN B, whatever situation happens, for example, in that case, I want to define a port number. So int port number, and then I get that port number from somewhere, blah, 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 and it is like 555, for example, and then store it, okay? So if the port is open, for example, then get the port number. And then after the else, tell me port is closed, okay? And then I see that they come here and they say that, okay, now I want to use the port number and I want to, for example, like refer to the port number inside another method or something. But whatever I do, this port number doesn't work. The problem is that this port number, this variable, was defined inside this scope of if condition. And as soon as the if condition was resolved and done, the memory which had this information was dropped and the port number does not exist anymore. If I want to assign something to this port number inside the if and I want to use it afterwards, I have to define it before that scope. So I have to make it a more a variable for a bigger scope. So I have to define it here, and then here I just assign it. Okay, so it's defined before if. The if happens, it is assigned here. Then maybe if when the if does not happen, then I can have, like, for example, this console.writeLine port is closed, and then I say then, for example, don't assign anything to the port number, so it would be null, or assign port num equals to null, which gives me an error. I'll tell you why, because it's not a nullable value. This is something that we talk about later. But then you can then check if the port num is null, not null, then do something, then use it. If it's null, then do something else. So in this case, the port num lives after if, but if you define it inside the if, it dies as soon as if condition is done. As soon as this curly braces is gone, as soon as we enter else or we exit the whole if condition situation, we don't have anything called port num anymore if we define it inside the port num. So is that clear? No, it gets the value. It's not empty. It gets the value. Yeah, it gets the value. But if you define it, but yes, yeah, 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 exactly. Let's try that actually. Let's see. Okay, we can see that easily here. So here we have the int port num outside, and in this case, which is like true, so it doesn't happen, I would say true false. So we go inside this situation, and then I would write console dot write line console.writeLine port num. Okay, so the error that you have here is that use of unassigned local variable. Why you get that error? Because this value is defined there, and we have this console.writeLine there. So the interpreter of C# always tries to avoid running into errors, and this is a situation that it knows that, hey, 50% at least, it's possible that I run into a situation that causes an error and I have to close the program with an exception error. So, and user have no control anymore afterwards. Why? Because there is an int port number defined here, but then it's not assigned. So it doesn't have a value. It's just a number. It's just a symbol, a name for something with no values. And I don't care. Maybe you never go inside this if situation to assign something to the port number. And then I don't have anything. So what should we do? We should assign something to that to be able to run this code. So I would assign 0 into that. And this error is gone. Okay? So in this situation, I run the code and I would say 555. Why? Because this yeah, it happened and it stayed. Okay, so now the question is that if I take this and put it here, then I would again get an error here. This time the error says what? The error said the name port num does not exist in the current context. Okay, what does it mean? It means like, hey, you defined the import num in this context. You didn't define anything here. This context is finished and port num is dropped. There's nothing like port num here. So what should I do? I don't have anything. I don't have any reference to any memory space. What should I print for you? I don't have anything. So one question, can I define import num also outside or not? Before I paste, what is your opinion? Can I do this? Does it work? To have, so if I assign something to it, does it work? If I assign 0 to it, does it work? No, it doesn't, because here it says port num is already defined in a bigger context. So if I look at here, it says a local or parameter named port num cannot be declared in this scope because that name is used in an enclosing local scope to define a local or parameter. It's already defined. So to fix it, I have to just delete this line, which is the declaration, and then everything is okay. Okay? Mm-hmm. Yes? Yeah, that works then. This is fine. Yeah. Yes, because it's a redundant operation. I assigned 0 to port num once, which it already had it. So I could write whatever. I could write, I don't know, 6666, whatever. It doesn't matter. And then I assign a new value. So this matters because this is the second value that I assigned. So when I run this, I still get 555. Clear? Okay, perfect. So there is another situation that's also another kind of condition that's also very useful. I explain it quickly. We are not going through it because I don't want to waste time constantly explain to you expressions of C#. Another thing is switch. So what are the switches? In a switch, you can have an expression, you can have a switch case and an expression, and then you can check different cases. So sometimes you have, for example, a situation that you say, okay, if this variable equals 5, do something. Else if this variable equals 6, do something. Else if this variable equals 7, do this. Else if variable equals 8, do this. Else if it's whatever, so else, do something else. Okay? When you have such situations, we have a more interesting condition syntax that we can use, which is called switch. So we say switch expression. So what is it that we want to check? So it's, for example, let's write it there. So here we have let's write int a equals like 5, and then we say switch, enter, expression a, then I enter, so I would say case. So here you would say this is the expression, and then you would say you have to open the curly braces. So we have case 1, then we see here it's case 1 column, and then we have a break. Okay, so case 1 column, and then case 2 column, and then there is also a case else. So it's like the case else in C# is called default. Okay, so you can call default equals what happens. And after each of these, you need a break, because the way that it works is that if you don't break it, it's going to check all the lines, which can be redundant. So you have to break it. So I would say in this case, like write console dot write line like hello, then here I would say hello 2, and then here I would say hello default. Okay, and then here I have to break again, break here, and again break here. So I need to bring this back. One thing, if you're using Visual Studio or Visual Studio Code, is that when you have this sort of messy code, you can select all and then automatically clean it up. So here, if I run the code, I would say hello default, because it's 5, it's not 1, it's not 2. And if I have, I don't know, like let's say 1, then I would get hello. And if I have 2, I would get hello 2. So you see, that's pretty easy. Okay. And if you forget that, yes, exactly. It's a special case. But there are some times that like this is much easier to implement, and this is more like helpful. Yeah. So next thing that is important, and we are going to talk about, are the loops. So this is of course something that's very interesting in Grasshopper as well, because you don't have loops in Grasshopper. So we have different like formats of loops. Two kinds of loops are very similar, which are while loops and do loops. These two formats are both based on a condition, so they continue upon a condition comes true, until a condition comes true. So you always have to also be very careful about these loops. If you write a condition that is never false, or that never turns false, this loop wants to continue forever. And this is when your program crashes. Okay, so these infinite loops are something that is dangerous, and it's always possible to get these loops with while loops and with do loops. Okay, how do they work? So while loops, you write the keyword of while, you open the parentheses, and you write a condition inside the while. So for example, I would say while I is less than 5. And then inside this condition, I write something. Inside the curly braces of the while, inside the scope of the while, I write something. So for example, I write increment I and then print I. So this like shows me all the integer numbers from one value to another value when I define it. Okay, something like this. So let's just copy paste this code to our thing. So it's int I equals 0 while I is less than 5, console.write line I, and then increment the I. Okay? So I write it here, and I see like I get 0, 1, 2, 3, 4. Okay? So if I write here while I equals I, what would happen if I run this? It go infinite. Exactly. That's the point. Yeah. It's like if you say if true is true, true is always true. It's never false. Yeah, it was very clear. You were very fast in answering that question. It was obvious that you had this situation before. Everybody has it. Like, and it's also possible that like this is the obvious case. There are times that like you're coding something and then suddenly you write a condition and before thinking about it, specifically when you're doing some sort of creative and generative coding, you're thinking about totally different things at the same time, and you're thinking about the forms and vectors and whatever, and then you might define a condition that you run the code and then you suddenly say, oh, Rhino crashes. And as soon as it crashes, you remember all the information and say, oh, this vector is always that way. And it's impossible that this vector changes downwards. So the condition that I set is always true because this vector never changes. It's impossible that it changes. So I have a crash. So this is something that you always have to be careful. And there are methods for that, apart from just like saving your code before running. That's of course the best way, the first way of avoiding like losing code or information. But another thing is that, and one of the reasons that I said that I don't like this situation that uh, Rhino always compiles the code with save is that if you have an issue inside if you have, for example, an infinite loop and you save the code, but you don't want to run it, then you don't have a chance of saving your whole grasshopper component. You run into crash and you probably have lost everything up until the last save. But in a normal IDE, you save it. It doesn't compile it. You have an infinite loop. You save the code, but you didn't run it. So nothing is lost. Then you run the code and the program crashes. You open it and you realize what was the issue, and then you debug. But this is a bit more difficult, and you need to be more careful when you're scripting inside the C# grasshopper component. So you have to make sure that you're using tries. You need to have control over exceptions and things like that. So this is one example. Another, yeah, this is a problem. If yeah, yeah, exactly. Or if you're unsure of a line of code that you want to check, you can just comment out that line of code, save everything. It may give you an error, but you can save everything. Then you come back, you uncomment it, and you run it, and you see if it works. This is the same case for things that are that need a lot of computation. So sometimes you are dealing with a situation that needs a lot of computation. So you just comment out that line, you save everything, then you run it. Then maybe you need to sleep for the computation to happen, or maybe the computer crashes. So these are not common cases, but with our demands and our computers, these can happen from time to time. So, mm-hmm, mm-hmm, Depends on your IDE and interpreter. Actually, I don't know what happens inside the Internet Explorer. We can try and see. Let's see. I don't know what happens here. Grasshopper crashes because it constantly wants to print. You tried? Ah, yeah, yeah. Okay. Yeah. In Visual Studio, it stops the compilation of the program. You don't lose code. So if you run such a thing in Visual Studio, the Visual Studio doesn't have a problem. You stop the compiler, you go back to code and you fix it. It's not a problem. With Rhino, it's not that easy. Let's see here. If I run it, then you see it's constantly like outputting, and you basically cannot stop it or do anything. Usually in terminals, Control C works, but not here again. And you see, okay, destroyed completely. So I have to close it. And yeah. Mm-hmm. And I think I lost the compiler also. I should exit the focus mode and start the focus mode again. No? Yeah. Yeah, I lost the compiler even completely. Yeah. So where was my code? It is in general here. Oh, it's still compiling. No, it's fine. I think I have to close the whole uh, Edge Explorer completely. Hopefully. Yeah, yeah. This is the infinite loops are one of those like really crazy issues. Yeah, now it's back. So it's inside the core of the edge. So I had to close all of the edge tabs that I had to be able to come back. Okay, so that's good to see. But it's much easier if you run into such problem most of the time in Visual Studio. Okay, so we go back to the where were we? We were in the for loops. In the loops. Okay, here we have we talked about while loops. So the point is like in while loops, the condition is checked first, and then it runs the code. If you want to check the condition after the first round, then you can use do loops. What's happening here is that if you are if you're using do loops, you get, for example, here we define int counter equals 0 do console.writeLine. Hello world, the counter is counter, so the counter is 0 for the first time, then counter plus plus, while counter is less than 10. Okay, and then here we say int counter equals 15, and then we say do console.writeLine. Hello world, the counter is counter, counter plus plus, while counter is less than 10. Here we get the output would be like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and yeah, a 9. Here we would get 10 as well. We would get 15 because it prints the first one. It runs the first code. Then it realizes that, oh, counter was not less than 10. Why did I do that? I don't continue. So just to show you how this works, I can copy this code and run it here. Here. So if I run this one, you see that we would have like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, because like it starts with 0, then it prints 0, adds to the 0, it becomes 1, then checks the condition at in the last point, it's 9, it prints 9, It adds 1 to the 9, it's counter plus plus, it makes it 10. Counter is not less than 10, so it continues here, it doesn't go back again. Okay, and if I run the other code, this one, you will see that I would get 1 time 15 because the counter is 15. It enters this scope of code anyways without checking any condition. Okay, then it realizes that it adds to the counter, but before adding to the counter, it prints the counter, which is 15, and then it realizes, oh, counter is not less than 10, so I don't continue. So this is important. Why this is important? So the point is, like, if I actually have this while, if I take it, Control X, and put it up there, what would be the result now? Do I get any output or not? None. I think it does. Yeah, I think it does. Yeah, I think it does. As far as I remember, it does. So here we do while counter is less than 10, do this, and it doesn't work. Okay, so there was one typo here. Again, this is another situation that you might get confused. So if I have a semicolon here, it's like while counter is less than 10, done. And then I have a block of code which is being run. So if I run this, I would get 15. It doesn't mean that it went through the condition, because even if I have like 5 here, what happens here? It's again an infinite loop, because it's like while counter is less than 10, what? I don't know. Wait. So again, we have to close the Explorer because this is an infinite loop and we never get here. Okay? No, it's not. It doesn't even reach there. It doesn't even reach there. I show you what happens. So what happens here? This semicolon in the syntax of the while. Look at here. In the syntax of the while, we have while condition curly braces open, curly braces closed. Okay, right? Mm-hmm. Okay, okay, okay. So here what happens is that we have while condition without a semicolon at the end. But when you have a do condition, you have a semicolon at the end of the while. This is something that you have to take into consideration always. Okay, so exactly. But this is a condition and it's not the end. We just started a curly braces. Okay, so that's how the interpreter works. Okay, and understands the end of things. So this is something that you have to be careful of. That if you change a while into a do for whatever reason, you make sure that you omit, you delete these semicolons, the end of the line. And this is very interesting because sometimes you want to run a piece of code anyways, and then if it didn't work or if something worked, then you continue or you do not continue. This is something actually sometimes really handful. So the most interesting loop of all languages, for loops. So for loops, in some languages are easier to interpret. For example, like if you are interpreting for loops in a more human language, like Visual Basic is like, uh, I think it was like for I, for example, uh, yeah, I forgot the syntax of Visual Basic actually, so forget that. So it's like, but it's more human. So when you read it, it's really clear what's going on there. In C Sharp, C++, quite similar is the Java and the Python, and many of language of the same level are for statement 1, statement 2, and statement 3. So what are these statements? Uh, and you have semicolons between the statements to be able to like turn them into blocks. Okay, so how does this work? So statement 1 is only being executed once, and it does define whatever is needed for your for loop scope of code. Okay, so it's like here we have an example. It's like for int I equals 0. So it once defines the int I for this for loop. So this int I, this I integer value is accessible only inside the for loop, and it dies after the for loop. Then statement 2 is the condition. So it says up until I is less than 5. So as long as I is less than 5, you continue incrementing, you continue the loop. And then the statement 3 is executed every time after the code block has been executed. So every time we run this, we go back here, we see what's this statement, and the for loop runs this statement for us, and then it goes back. So it could be I equals I plus 1. It could be anything. It could be a method, whatever. The only thing that you should be careful of is that this method should somehow affect the I. Okay, however you want, doesn't matter, but it should affect the I, because we have I equals 0. This runs unless I is less than 5. If this statement does not change the I, then this loop is again a forever loop. So this should change the I somehow. And so many cases, if you have something wrong, the C# interpreter gives you an error and doesn't allow you to do that. But it's like, so here we say, for example, I++. This means what? This means run the for loop. The first I is 0, then run it up until I is less than 5, and each time add to the I. So, but it doesn't do it the first time. So it starts with I0, then it goes here, 0 is less than 5, so go into the block. Right line, so it writes 0. Then go back. Is I still less than 5? Add 1 to the I. 1. Is it still less than 5? Yes, 1 is less than 5. Go back, write 1. Then go up again, add to it. It becomes 2. Is it still less than 5? Yes. It's 3, it's less than 5. So print it. Again, continue. And the last time it goes up, it says like I add to it. It becomes 6. Is 6 less than 5 or makes it 5? Is 5 less than 5? No, 5 is not less than 5. It equals 5. So it doesn't print 5. So it prints 5 numbers, 0 to 5, 0 to 4. Okay? So if I copy this code and then I go back here to the console and define this, run, you would see 0, 1, 2, 3, 4. Okay? Any questions? I think this is probably. I think because it was the first code that I ran this time, no? Yeah. Because it was running, when I opened this tab again, I think I didn't run any code there before. It was opening the compiler. Around while, do, and for. Not that I know. It depends on the operation. But I actually was never checking to see how they really behave in terms of computation and memory. It's an interesting question. I will check. I'll let you know. I never checked myself to see if there is any difference. So I never checked if I want to do the same operation of printing from something to something or do the same operation with both, which one is faster. I will check. Sure. Definitely, there is no difference between while and do because they are using the same sort of engine. Between them and for, I don't know. I should see. But I don't think so. Yeah, it's the same, but I don't think there is any difference, basically. I don't believe there should be any difference. So we have another thing, and here I was talking about like infinite loops, and then we have for each that I explain again a bit later when I'm talking about lists. Then we have infinite loops, which we talked about. We already suffered from it, we experienced it. There is another thing which is important about loops. That is a question that I get a lot. You saw earlier that we used the break command inside the switch case system because we wanted to break a case so it doesn't continue and check other cases. We can use this break and continue, break and another keyword which is continue inside loops and inside other code blocks as well. So for example, here, if I have a for loop and if I have an if and then I say break and console.writeLine, it basically what happens is that each time it goes here. If I is not 4, it doesn't break and it writes it. But if I is 4, it breaks this whole condition. So from here, it jumps to here and goes back to 4 and it doesn't write 4. This is very important because sometimes you can use this technique to, for example, bypass some elements of a list. That list might be a list of points or lines or whatever. Maybe you can use such a simple thing to basically produce a pattern, to generate a pattern, to generate holes inside the surface or whatever. So these are all interesting things you can use to generate form. So if I run this, you would see that we have 0, 1, 2, 3, but not 4. Why? Because at 4 it breaks, okay, and it ends the whole 4. But what if I want to jump 4, but I want to basically how to say print the rest? I can exchange this break with continue. So if I make it continue, what happens is that, so here it continues, it means that it jumps. So it's like 0, 1, 2, 3, 4 doesn't exist, 5, 6, 7, 8, 9. Okay, is that clear? So break breaks the whole operation, continue breaks the operation from here to here. So it jumps the rest of this operation. And it doesn't do the console.writeLine. We can actually say here, I don't know, we can say console.writeLine. Hop. Oh, I should do it before continue, sorry. So you see, instead of 4, it says hop. So that's the situation. So remember the break and continue if you see them in the code or if you want to implement them in the code. And now if you don't have any questions, we can go to the next concept before giving a break. Any questions? Perfect. Mm-hmm. For this, you need to get to real proper resources. I think this is something that you cannot even trust ChatGPT. There are actually computational books for that in computer science. I need to check those. So it's like this is not usually a question that you can get from any resource online easily and trust. Uh, so, or you can basically try it yourself in isolated conditions, but that's also difficult because you need to make sure that your computer is in the same situation when you test both. So something changes, the temperature of the CPU, whatever changes, you are not sure anymore what was the reason of one operation being faster. Yeah, sure. What I know is that for us in this situation, it really doesn't matter. So it doesn't add anything to our time or save us any money or save us any computational anything resources for the operations that we do. Whatever we do for both of them would be quite the same. Then after this, I want to start talking about lists and collections and everything. And there are two ways of talking about these things. One would be I just tell you there are lists, and these lists are defined like that, and I explain this to you very blindly. Another way would be I start telling you something about like object-oriented programming, so you start to understand the concept of classes and everything inside the realm of object-oriented programming. And when I explain you the collections and lists and arrays inside C# or any other language, you then understand that, okay, what are we talking about? So what is the difference of a list versus an int? Why list behaves differently comparing to double? Why a list can be a list of double or something? Then you understand these things much better and much more clear. So one question. Does any of you have a good understanding or any understanding or perfect understanding of object-oriented programming, or you just heard something? I'm sure you heard something about it, but what's the situation right now? And Kesra? Okay. So object-oriented programming is a very interesting topic and it's very important. So it's basically a sort of programming approach that started long time ago already. Uh, we have it in languages like C#, Java, Python, and also C++. Right now, also Visual Basic. But there were talks back then that the people were saying like it was this sort of thing between programmers like hey. You're writing Visual Basic? Ha ha ha. Visual Basic is not an actual object-oriented programming language. Ha ha ha. Or, oh, you're writing C++? C++ has issues with object-oriented programming. Java is the best object-oriented programming language. And there are reasons for those things. Because there are situations, they're rare situations, and there are still in some languages, that the language is not completely following the rules of object-oriented programming. And is it a good thing or a bad thing? Sometimes it's a good thing, sometimes it's a bad thing. So it depends what you want to do and how you are aware of something. So just one classic example is that there are object-oriented programming languages. There are programming languages that they are called object-oriented programming language, but they can have exceptions. One exception is that, for example, in a fully proper object-oriented programming language, one object can only have one father, like the real world. So literally, in human beings, not in cats. In cats, it's different, but in human beings, one person can literally have only one father. You cannot have two fathers, two biological fathers, as a human being. Uh, at least not. Maybe it's possible now in lab. I don't know, but in real world case, it's not possible. But some languages uh, they allow you they allow the object to have more than one father. So this is basically not object oriented, but it behaves according to those fathers in special cases as fathers, and it derives from both those fathers. But what are all of these means? Like, why do we even need to know these things? Why do we even need to use like object oriented programming? there are different ways of programming. So like you've probably heard like procedural programming, functional programming, object-oriented programming. There are different concepts and methods of programming, and each of them are helpful for some tasks and some operations and some work. One of the very interesting ones, which is still going on, and when we are coding inside Rhino Grasshopper, we are basically dealing with an object-oriented environment, is basically object-oriented programming. So what does that mean? Basically, in object-oriented programming, you're dealing with objects. These objects have qualities, have methods, have systems of work, have properties, and have internal things inside them that you can use, but they are also at the same time protected. At the same time, you can have basically sort of blueprints from these objects that then you can make examples, or in a correct way, instances of those objects. So what does that mean? It's like imagine that I have a specific blueprint of something, and then I can produce several of that thing with that blueprint, several cups, several cars, several animals, whatever. And that blueprint on the top layer, which we call it usually class, is something that defines the behavior, the form, the shape, the properties, the actions, and the reasons of the existential reasons of that object. So how do we define that? For example, let's say we could have a bigger class, a bigger definitive class, which is called animal. Then we can define in this animal everything which all animals have. So you can say, okay, all animals may, for example, have a sound, have a voice. All animals have eyes, for example. All animals have moving mechanisms, or blah, 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 or something, or gender, or I don't know. Maybe actually not all animals can have gender, but whatever. Something that all animals can have, okay? But then we start to specify things. So, for example, then we are defining under animals another type, another class, which is called, for example, cats. Then we know that, okay, if you have an animal, then there are types of cats. So, for example, there are cats with these sort of things. So they have legs, they have a tail, they have ears, they have eyes, they have fur, blah, blah, blah. Then we can have another system, which is then defines the type of the cat. So, for example, is it a lion? Is it a tiger? Is it a cheetah? Is it, I don't know, is it a domestic cat? Is it like whatever? And then you start defining more specific categories. So why is that helpful? Because when we know that we are dealing with something like animals, we define a bigger blueprint. Maybe I define that blueprint with all the information of that, and I take care of all those information. And I'm always working on that information. Then I deliver this class to one of you, and then one of you is defining, for example, the category of cats. And then you deliver that to the next person, and that person starts to define tigers, another person defines lions, another person defines something. So you're working in different scopes. And if something with the whole cat is wrong, you as the person who is working with tigers do not need to worry. The person who does cats take care of that, fixes it, and it's automatically fixed for you also, because you are inheriting everything from a cat. Wherever necessary, you change it. Wherever not, you keep it as it is. So the person who takes care of the cat takes care of it. If something is wrong with animals, you don't need to be worried about that. I, as a person who develops the animal class, fix that issue, and then you're already gonna have that issue fixed. So if animals are starting to have a specific weird behavior and behaviorally in the system of the program that we made, then, and we know that the issue is because of the mother class, which is animal, then I have to debug that. I have to solve the issue. But if we see that, okay, animals in general don't have a problem, but now inside animals, inside the territory of animals, only cats are behaving weirdly. Then we have to go, for example, say, hey, Anal, you are dealing with cats. Find what's the issue with the cats. And then you debug the cats. And then everything goes right afterwards. So this is one of the reasons that it is like, it's really important to do that. And this concept of like defining these scopes and defining the territories, controlling the territories, is somehow, it's called encapsulation in object-oriented programming. So we have different basically concepts of concepts inside object-oriented programming. So we have encapsulation. So which is like, if you want to define it, like encapsulation is like putting data and method into protective containers. So it's like I'm defining something. So for example, like let's say here, we're defining a class of car and we're defining speed for that car. But as you see here, this speed is a private speed, okay? So what happens here is that someone from outside the car class cannot change the speed without our consent. So anytime the speed changes, we know that it changed. So we know that we should do something about it. Either it's too fast, so we have to brake. Either it's too slow, so we have to speed up, or whatever. So we always have control. So it helps us control. Then we have abstraction. This is also another important concept in object-oriented programming. What's abstraction? Basically, it means that you are avoiding complexity and you deliver something to people that they can basically use. So let's say you're using a class which is called point3d in Rhino, in Grasshopper, or you're using a class which is called KERF, or you're using a class which is called polyline. You don't need to know what's going on there. You don't need to know how many references is there. You don't need to know how this class basically draws a polyline for you on the screen, with what graphical units it speaks, how does it change everything, how does it calculate everything. You just say, hey, there is a class of polyline. I want to make an instance of this polyline class. So it means that I define an instance. I call this instance, for example, my polyline. And then when I'm making an instance of this polyline, I'm going to tell this polyline class that these are the points that I want for you. So draw lines between these points. And that class, the mother class, the main class of polyline, will take care of everything. And it defines and it shows the polyline for me on the screen. So this is abstraction, because the whole class abstracts everything for me and it makes it easier. And I don't need to do anything. And for example, imagine that I want to define a specific type of polyline, which is my type of polyline. I know that the behavior of my polyline is similar to the general polyline, but for example, my polyline always shows itself as a dashed line instead of a continuous line, for example. Then I can say, hey, there is a mother class called polyline. Take that mother class, and I'm gonna inherit from that mother class. We come to the inheritance. So whatever that mother class has, this is the same thing that we talked about animals. Whatever animal has, whatever polyline has, I have. So I don't want to know how those things are solved. I can also draw lines. But at this time, when you drew the line, give it to me. I'm going to break it into several segments, and then I deliver it to the user. So my polyline, which is, for example, called like dashed polyline class, is a class that always delivers a dashed polyline instead of a continuous polyline. Okay, so here we see an example here. It's class animal, public void eat. So all animals eat. And it says console.writeLine eating. Our animal is eating. Okay, but then we say class dog, and then we use a column animal. What does this mean? It means that the class dog inherits from the class animal. So it means if we are writing animal dot, we only see it inside the animal. So the animal class only has one method, one behavior, which is eating. But the class dog has one method, which is barking, and it derives its properties, its behaviors, its methods from animal, because it's inheriting everything from animal. So whatever animal has, dog has too. So if you write something which is an instance of dog point, you would say there is eating and there is barking. So this dog thing has two. While inside the code, you only see there is one line of code. But because of this line, we already have everything inside. It doesn't matter if it's one line, if it's like whatever, if it's like one method or 1,000 methods. You inherit everything. And then we have polymorphism inside object-oriented programming. This is also very interesting and important. Why? Because maybe I have a class of animal and all of the animals speak, okay? But if there is an animal, it just says like animal sound. But if I'm driving a dog from an animal, I take the speak. I still call it speak. So anybody who is using a dog, because they know this is animal, they know there is a method of speak inside that animal, or they know there is a method of eat inside that animal. Okay? But the dog says woof, or the dog eats, for example, I don't know, meat. If there is, I don't know, a rhino, the rhino doesn't eat meat. So I cannot input meat into rhino. So I have an eating like input and eating properties for dog and eating properties for the rhino, but or eating properties for grasshopper, for example. So one of them can only receive insect types, one of them can receive meat types, one of them can receive maybe any types. I don't know. That's the point. So one of them behaves when with the speaking method calls. One of them says mew, one of them says hoof, one of them, I don't know, does something else. One of them is mute. I don't know. So that's the point. So this is called polymorphism. So you have different things. Another thing that you're familiar with about polymorphism is overriding, is method overriding. Do you remember what is method overriding? Here, you see when I say console.writeLine, exactly. So we have 18 overrides for the console.writeLine because console.writeLine can behave with 18 different methods. So actually, when we have a class, the class of console has a method called writeLine. But if you go to the code of the console class, you see there are 18 different types of methods defined there. All of them called writeLine, but one of them doesn't have any inputs. One of them has only a Boolean input. One of them has a character input. One of them has a character array input, which could be also a null. One of them has a character buffer and has an int as index and has an int as count. One of them has a decimal, blah, 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 so on and so forth. Okay, so this is also polymorphism because we have two types of polymorphisms. We have runtime polymorphism and compile time polymorphism. But this is something that I don't want to like talk about it right now. This is more than this course. So was it all clear so far? So yes, we do. After, do you want a 5 minute break? 5, 10 minute, like we start again at 8. Is that good? We can. Yeah, okay. So in 1 hour. Okay, so I just refill my cup with some water and we continue. Okay, so we continue at this point, now that we understand this, we are going to talk about the methods. We are going to talk about classes first. That's better. So now that we understand how this whole like situation of like object-oriented thing works, the main object, the main blueprint thing that we define inside the realm of object-oriented situation are the classes. So how do we do that? So if we want to define something, we need to define it as a class. So let's go to the code. I guess that's easier and more understandable here if we go here. So let's start with defining a class. Here we don't have a point3d class, so let's define a point3d class. Okay, so we can define a class which is called which can be, okay, let me show you here the situation. So in a class we have the first word, which is public, private, one of these. This defines the scope of readability of the class. What does that mean? This means that who can access this class? Is it a class which can only be accessed inside the scope of code that is there, and it's defined for us inside, or is it a class that can be accessed from outside as well? Okay, this is something that you always have to define, because sometimes you define classes inside the class for yourself to do something. Sometimes you define classes inside the class for others to use. What is the difference? When I say classes, we have classes and namespaces. Okay, so let's go quickly to Rhino. Here, when we go to the regions system, we see there are using system.link, using system.collection. These are all specific namespaces inside .NET. These namespaces are bigger containers of classes. Each of these namespaces can contain other namespaces or other classes or modules that we can use. So, for example, here we have a namespace called Rhino. If I write Rhino dot, I see here that I have different forms. So I have something there which is called enum here. I have something which is starts with curly braces, which is a namespace. So rhino.application settings is a namespace. Rhino.commands, rhino.display, rhino.docObjects. Let's say rhino.geometry, it's a namespace. So if I go to rhino.geometry dot, then I see, for example, we have classes here. You see, each of them has a different sign. So there is a class called arc. There's a struct called arc. There's a class called arc KERF. There's a class called struct called bounding box. There is a struct called box. There is a class called brep. So if I choose brep and say dot, what's happening here? Okay, inside brep, I have different things. I have properties. I have like methods that I can use, and I have functions or something. So here, this sign, this cube sign, is defining a function that you can run and you receive something from it. So for example, if I choose like something like create shell, I can create a shell with some inputs. So if I say create shell and I open parentheses, I see that it says, okay, I have only one overload. You want to create a shell for a brep, and then you should tell me something like, do you want faces to remove or not? And what is the distance? What is the thickness of this shell? And what is the tolerance? So if there is a space, there's a specific form of the brep, how close should be my shell to the edges of that brep? So these are information you need to say. And then by running this basically goes to the class of brep, runs a method which is called create shell, does something, and then returns to you a brep array. Okay, so what's happening here is that if we want to define a class, for example, I can define public. Okay, so public class, all lowercase, and then let's call it point3d. Okay, so this is a class that I define. So what should I do now? I can open and close parentheses and write braces. So is it fine? Does it work? Don't I need to define a type for the point 3D? Do you know that? Should I define a type or not? I don't need to, because the class itself is a type. So if this class wants to derive some information from another class, I can basically, like here that you saw in the previous example, I can use a column and then derive it from another class. So you see here inside Rhino, we have public class script instance. This script instance is the class which defines that container of code that you have, is that component, that grasshopper component that you have. You see, this is the highest level of code that you have here. So this is script instance, and there is column, there's a gh grasshopper script instance, which is an interface, which is a mother blueprint. So this script instance gets all of this information and values from grasshopper instance value. Inside that grasshopper instance value, there are several things. One of them is a run script, and we are overriding that run script. So we are taking those information and say, hey, you have the run script, your run script is empty. I'm going to fill it with my code. There are other things that you can also override. So it's possible that you write something else here as well, but we don't get into that right now. Okay, so this is, again, the definition of inheritance here. So we define the class. This is the name of the class. This is the name of the type. And then we got information from somewhere. We don't have to always. Sometimes we can define the information ourselves. Okay, so we have a class called point3. Okay, so what does this class have? This class should have some values. Okay, so it should mean something to us. Let's go back to this description here. So here we define the class car. It's like public string color, public int speed, public void start. So what is this void start? This is a method inside this class. So I just open a big parenthesis and we go to methods because we want to slowly define everything inside classes. Okay, so these methods, what are these methods? So you can define methods inside your own classes or inside other people's classes or inside any class that is there. So the point is, like, basically this script instance inside Grasshopper here is a class which is somehow ours, somehow not. Because we define it here, it's ours because we're using it. But it's not ours because this is something that delivered to us, it's delivered to us by Rhino Grasshopper environment, by Rhino Common and Grasshopper kernel. Okay, so but what I can do, I can define my own methods here to be able to use it. Okay, so how do I do that? To define methods, we again need a specific to follow a specific syntax. So there are access modifiers, return type, method name. Okay, and then the code to be run. What's the example? So the return type could be nothing or could be something. So when it comes to methods, methods are something that you can you probably also know as functions also. So what's happening is that you can have different sort of methods. So the methods could have no outcome. So they are void methods, as you see here. So there's like public void greet. And so it says like, hey, hello world. Okay, so it does something, but it doesn't give you something. You remember we had situations that something had to be run always and had to be poured somewhere. Those are the methods, situations that are returning a value. And there were sometimes like console.writeLine. It does something, but it doesn't return a value, right? But when we were using last session, we were using something which was returning. We were using the try parse last session. So the try parse was returning a Boolean value. So basically, you cannot just run a try parse on the air. You have to do something with this value. Okay, but a void can be run on the air, and console.writeLine is a void, so it does something for you. Okay, so for example, we can have some values inside our point 3D, and we can say, okay, a point should have an x. So let's say public. What is x? It should be usually, let's say, a double value. Public double x equals 0, 0. I have an excessive dot here. Okay. Then I can define y and z also as values here. Okay. And then I can define a method here. So I want this method to be able to be called from anywhere. So I can say, okay, public public. Let's call it public void. Let's call this method print location. Okay, print location. And we open and close the parentheses, and then we basically open and close the curly braces. This method basically doesn't do anything right now. But for example, let's say that we want to be able to define the location of the point here. So how do we do that? We can say we show the location of the point here. So we say console dot right line, and we say then do it like that. So dollar, then we say x, y, and z. Okay. Okay, perfect. So if I run this, nothing happens because I don't have anything to do there. Okay. Someone left. Okay. So I don't have anything to do there. So how can I use that? I can basically define an example, an instance of this class here. How to do that? I can basically come here and then start defining the class. Let's go back to this code and see what happens here. So we are defining, we go back to the class here. So we have this class. How do we define that? If you have a class which is called, this class has two public variables, two public values, and a public method that could be called. If I want to define something of this class, I should use the name of this class and then say car space my car equals new car. What does that mean? How do we translate that? So car is the type of this class. So basically, when I'm saying car, this car here, okay, when I'm using this car here, basically this car is this one because this is a type that I have here. Okay, then again, we have this car thing here. Okay, what does this refer to? This refers to the constructor of the class. What is a constructor? We see this new line here, this new code here. This new code is basically telling us that this car class, which we call the instance of it a my car, should call the constructor of the class and make a new instance of the class by that constructor. Okay, so we can always have a method, define a method for every class that constructs the instance of that class. So Why do we need that? Because sometimes when we make a class, we need to initiate the values and the situation of that class. So for example, if I make an instance of a curve, that that polyline at least needs 2 points, because a polyline without 2 points means nothing. The smallest polyline at least should have 2 points, okay, to mean something. So when we want to make a new polyline, we need to have a constructor. We need to have a method that forces the user to give us 2 points, for example, and then by receiving those 2 points, we are able to generate and show the user the polyline. But why we are able to use this is, are we able to use this, or is it going to have an error? We are able to use it because there is always a default constructor for every class we define, and that default constructor is empty. It doesn't do anything. So basically, we are not initiating anything inside that class, anything. So what does that mean? So if I go back to the code, I have a public class point 3D like that, and then public void point location, console.writeLine, XYZ. Now I want to make a new instance of this class. So I would say then point 3D pt. Oh, point 3D pt equals to, so go back here, so it's like this one, equals to new point 3D open close. So it basically made a new point 3D. If I write pt dot, then I should be able to basically access the methods of that point 3D. So I can say pt dot print lock, and then I should run this. Let me copy that. I think there is an issue with my compiler again. I have to close this and open it again. Mm-hmm. Mm-hmm. Okay. Well, what did you mean? I thought you left. So what did you miss? What parts? Ah, okay. Mm-hmm. Okay, I'm gonna explain it. Don't worry. So, so what do we have here is like we are, no, 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 it's not the constructor. So I explain quickly everything here. So I defined a public class basically here. Okay, so we go back to this code here. So we can define a public, we can define a class, and this class can have some basic variables. And so it's like public string color, public int speed, and public void start. And then there is something in that void start. Okay, then it is possible basically to make an instance of this class somewhere. Okay, and then use that instance. Okay, so if we say car, my car equals new car, then it makes an instance of that car. So I can say my car dot color, define the color of that car, then my car dot speed, and then say my car dot start. So at this moment, this car just tells us that it started and it doesn't do anything. Okay, so how can we start using this whole thing? Basically, we define the class here. So we said public class point 3D, and then let's just make it a specific name that I'm not sure. Maybe there is a point 3D somewhere there. Okay, so Okay. Yeah. It's a method. It's a void method that we define, like the start here. Yeah. So we have the print log here, and then we say there is a my.3d. So I call it my.3d of pt equals new my.3d. Okay. So we basically did point 3d. Then when we say pt dot, we should be able to run this print log basically. So if I write print log and then I open and close the parentheses and I close. So it gives me an error. It says invalid token in class record struct or interface member declaration. What am I missing here? It should, yeah. Let's run this inside Rhino because I actually have never done this sort of thing inside the console, just standalone. I'm afraid that it is something related to here. So let's here inside Rhino, inside this class, we are defining inside this space, we are defining a new public class. Mhm. Actually, you know why it's not working? I did some mistake. It's like I have to eliminate this one. That's the point. Mhm. Mhm. So let's go to Rhino script, and then I define the class here. So it's like a public class my.3d, and then we should see if we can. Should I bring it here already? Yes. So we define the class here, and then here we should be able to access that class. So if I try to basically make my.3d, here it says like is a type which is not valid in the given context. It's inside that context. So here it's like I say my.3d pt equals my.3d, okay, equals new my.3d, and then I close the line. So I basically made a new PT, okay, and then if I have a method here, I can start using PT, okay, here. So it's like basically PT should be, it's a private void, so it shouldn't be able, we should not be able to, we are not able to access it here probably. PT dot. It works like that. So pt dot print log. So then if I write that and then I run, I would get the 000 position here. Okay. So as you see here, I think that was something related to the context of this code that it's not working. I should just check to see what's the issue. Probably I have to define a mother class there as well. It's not that open. So here we define a public class, my.3d, and we define x, y, and z values for that. And then we made a public void print log, and then console.writeLine X, Y, and Z. So it defines the X, Y, and Z. Okay, so the question here is that what happens if I want to already define the X, Y, and Z of the point 3D when I'm constructing it, okay, but not able to change the values outside. So right now here I can say pt dot x equals, for example, 100, and then close. And if I run that, I see that it's 100, 0, 0, the location. Okay, but what if I don't want someone to just randomly change this value? What I can do is that I can basically change this into private. Okay, so, and I make it private, private, and private. Okay, so you see the error here is that I don't see any x there, because now if I write pt dot, I don't see any x because that's a private value. Okay, so how do we define that? Maybe I want to force the user to define that through a method. That method could be the constructor of the class. And in that constructor, I allow the user to input something to this value. So it's always under my control. Okay, so how do we do that? To define the constructor, the name of the constructor of the class is always the same name of the class. So it's the same thing, my point 3D. So I can say public void this, and we could have an empty constructor, or we could have a non-empty constructor. So what does it say here? Member names cannot have the same name as their enclosing type. So here we would say then x, we would say double x, and then again double y, and then again double c. So let's go back to the Obsidian page here. So we're talking about the constructors. Okay, so we say public car for the constructor. So when we want to define the constructor, because the constructor is a specific method, we are not defining any specific type for that. Okay, so when I was talking about the methods here, we said the method syntax is that the access modifier, so it's either public, private, the return type, is it a void, is it a string, is it a double, is it a list, what it is, and then the name of the method. Okay, but constructors are internal names, internal definitions. So when we go to the class, to the constructors, we see that we don't need to define this the type. We don't have to define the type, because these are basically internal methods. So if I remove the void and then I say public my point 3D double x double y and double c, and if you check, if you see correct accurately, this is big X and not a small x. I cannot use the same values because these are the types that I defined for my class, and these are internal types of the class. So if I write x here, a small x, I would get an error. Even if not now, I would get this error later. Okay, so I should make it just x. Okay, and then what I can do inside this creator is that I can say, okay, x equals x, then y equals y, and then z equals z. Okay, just 3 lines of code, and we are. Oh, sorry, that's why we have a error here. Okay, okay, and z. Okay, so now we are ready to construct, but we have an error here because this empty constructor doesn't exist anymore. And if we want to properly define the object, we need to basically give the values here. So here we can say 100, 20, and 50, for example. Now, if I run the code, I see this would be the value of my code. This would be the location of my new specific point 3D object that I define. So we can have other methods, we can have functions, we can have everything for every class that we define. But what is the reason that that we are even defining this whole thing and we are discussing this whole thing? Do you have any questions so far? Okay, so yep. So the point is, we saw here that when we wanted to define this point 3D, there were several values that we used here. First, we said my point 3D, which is a type. Back then, when we were defining variables, for example, we were saying int something, and it was turning into blue because it was a defined internal type, right? So now we are using a class name. So like, I don't know, my point 3D, or I can actually do point 3D, which is a class which is defined in Rhino. Okay, so I can say point 3D PTA equals new point 3D. Okay, and when I enter and open the parentheses, I see I have 6 overloads of point 3D that I can use. A point 3D with XYZ, a point 3D with a vector, a point 3D with a point 3 float point, a point 3D with a point 3D point, whatever. So I can define new point 3D objects in Rhino, or an empty point 3D, which is 0, 0, 0. Okay, and then if I write PTA dot, I get access to several operators and several methods that I can use. Okay, so I can get access to X and Y and Z. Remember, these X, Y, Z that you see here, they have this wrench sign next to them. These are properties of the point 3D. So what are the properties? Properties are entities inside classes that we define that are actually helping us encapsulate the information. So properties are not variables. So what I defined here, the X, Y, Z, these are variables. These are internal variables. These are not properties. But when we define a property, every time that property changes, the class knows that it changes. So when the user gives a value for the property to the class knows that, okay, someone gave me something. What should I do with it? And whenever user wants to receive that information, so when user says like pta.x, give me the x, then someone asks the class, hey, someone wants x. What should I give to that person? And then you decide what should you give. So you should either give the location or whatever else that is relevant. So you have control over input and output. Sometimes an input comes and you say, hey, this input is not what I want. This is too big. This is too small. This is irrelevant. I'm not accepting it. I'm throwing an exception. I'm throwing an error. Okay. So this is something that, again, we can have in class definitions. But why are we even talking about this? Because it's important that when we start to deal with specific types in Grasshopper, we know that are we dealing with types like integers, floats, everything, or are we dealing with classes? You remember I was talking about by reference by value. That's where this whole thing is very important, because when we are talking about types like integers and floats or whatever values of that type, we are basically doubles, booleans, structs. We are dealing with by value assignments of values. So if an integer value equals an integer variable equals another integer variable, the container, the containment, the information, the data inside variable B will be poured into variable A. But then if one of them changes, it doesn't matter, the other doesn't change, okay? But if I say, for example, a class of type point A, I have two class types, okay? PTA, okay? And then if I define basically point 3D PTB, okay, equals PTA. If I do that, okay, and when I'm defining the point 3DA, I say like 200, 200, 200. Like this is the location of my point 3D. Okay, and then here I say, okay, ptb dot y ptb dot y equals 500. Equals 500. Okay, and then I write console dot write line pta dot y. What would I get here? We get 200. Okay, this is because the system of a grasshopper works in a way that when you say pt, did I say ptp equal pta, and then I changed the ptb, and then pta dot, and I showed pta dot y. Yeah, it's not by reference. Yeah, so the point is like now if we are basically changing pta.y to 500 and basically showing the ptb, okay, we again get 200. Why? Because the ptb was changed there. So this is something that is important because when we are using these operators inside Grasshopper, you should know what happens in the background. Okay, let's try this whole thing with R point. Okay, so I'm copying this and I'm, yeah, yes. What are you talking about exactly? Mm-hmm. Ah, okay, that's the point. No, no, that uh, no, no, I understand your question. I'll explain it. Give me a few seconds, I'll explain it. I completely understand your question, and it's a very relevant question. You're talking about the scope of the operations, right? So we had this int inside the if, and then when we were using it outside the if, it was not understandable. That's your question, right? Okay. Okay. Let me clarify this first for you. Okay. So what was happening there was let's do it in a piece of code which is very clear. So back then, what we had was we had, for example, an if situation. So we had if whatever, okay, then there was some code here, and then we had int a equals 5, and then I said that after these curly brackets, you cannot use a, right? And but now you see that, hey, you told me this, but now you're referring to a variable which is inside a class completely somewhere else, and you're telling me that I can use it. How does this work? Is that the question? Okay. So the point is here we defined a variable. Okay. Let's say we call this person Kesra. Okay. This is a Kesra, and then this Kesra is only known in his own home somewhere in Turkey, somewhere in Istanbul, somewhere. Okay. So if in general I start saying, hey, I need Kesra to come here to someone in Vienna, they look at me like, who? Which Kesra? There are thousands and millions maybe of Kesras around the world. What are you talking about? But if I'm coming to, for example, to your place, to your office, where people know you, and I say, hey, can you call Kesra? Everybody knows who I'm talking about because Kesra means something in that context. Okay? But at the same time, there is a possibility that I call you from here. How? I can say Turkey dot, if you're, for example, in Istanbul, dot Istanbul dot, for example, I don't know, you are in a specific like region of Istanbul, or let's say in University of Istanbul, dot University of Istanbul dot second floor dot room 25 dot Kesra with your family name. Then it's very explicit. I am defining, I'm calling which Kesra. So everyone knows, like, okay, you're talking about Turkey, you're talking about Istanbul, smaller school, you're talking about University of Istanbul, you're talking about second floor, you're talking about room 100, for example, you're talking about a class, a person with this name and this family name. Okay, I have only one instance of that. So here, this is Kesra, it's yours. Talk to Kesra, do whatever. So that's how we deal with this variable. So we have a class here, and here the difference is that this class is still not the University of Istanbul, for example, and not your room. This is a blueprint. So I say that imagine there could be a University of Istanbul with that my point 3D with something. Then we are saying now, okay, let's make an instance of this class. Let's generate a new instance of this point, a new instance of this Kesra, which is similar to that Kesra that we have, which is a copy of that Kesra that we have in University of Istanbul, in that floor, in that room. This is the copy. Okay, so this copy, we know the properties, we know everything. And when I say, okay, my point 3D, which is a copy of that point 3D, dot, it says, okay, this point 3D has these values. Do you want to change it? Yes, I change it. So I'm basically penetrating inside that class with under the control of the class. I change something and then I save it somewhere. So next time I want to use, I say, hey, there was that instance of point 3D, there was that instance of Kesra that I made, and I defined something for it, and I said, hey, this Kesra knows cSharp, this Kesra knows Python, this Kesra is an architect. So that Kesra, bring it to me. Now ask this Kesra to design a building for me. Now ask this point 3D to help me draw a line. This is how it works. But yeah, you get it? Is it clear? Okay, perfect. So now it's like, so that is the whole thing. Okay, and now here is a very exciting and hopefully not confusing example. And this is a very important example. I hope you get it right. So the point is we implemented two lines of code which are quite similar because but one of them uses the normal point 3D of Rhino, and one of them uses the my point 3D that we defined, a class that we defined here. Okay, so if I'm running the code, the upper code, I'm gonna comment this, Control KC, And I'm going to uncomment this, Control KU, which is uncomment. So if I run this code, let's interpret the code together. It says point 3D, point A. So define a point A, okay? An instance, a copy of point A. A copy which gets its instructions from point 3D. Make it, and the location is 200, 200, 200. Then point 3D PTB equals PTA. So it says what? It says now PTA is PTB. Now we want to know what does this mean in Rhino. Why should we know what does this mean in Rhino? Because this is a class that someone else wrote, this point 3D. We don't know what's going on inside the point 3D. Someone else gave us this class. We have to understand. So either we have to go to the documentation of point 3D of Rhino McNeil and see, okay, what do they say there? How do they define it? Or we have to test for ourselves. So now I say PTA, so this value, this first one, which has a 200, 200, 200, and it's now poured into PTB. So PTB also has 200, 200, 200. This PTA.y is 500, okay? So if I have no clue of programming and no one explained to me anything about by value and by reference, I automatically say, okay, perfect. So if I print PTA now, it tells me 200, 400, 200. And if I print PTB's Y, it tells me 200, because back then, when PTA was 200, 200, 200, I poured it into PTB. And now I changed PTA.y. I didn't change PTB.y. So it's completely fine. We don't have to be worried. PTB.y is still 200, right? And I run it, and yeah, perfect. It's like that. But this is tricky. Why? Because now, if we basically comment this code and uncomment this code, it's exactly the same code, but this time, instead of using the point 3D that David Rotten wrote for me, I'm using a point 3D that we wrote for ourselves, which is a class. It has 3 values. It has a void. It has a constructor. It's a very normal, simple class. And I say, okay, my point 3D PTA equals new point 3D 200, 200, 200. My point 3D PTB equals PTA. So it's like I port PTA to PTB. Perfect. Then PTA.y equals 500. Perfect. What happens? I changed the y of PTA. And now if I print PTB, what happens? What should I see? Let's run the code. I see 500. Why? Did I write something wrong? Is my code wrong? No. What is the difference here? This is a very specific, important information that you should always take care when you're using libraries of people, and never consider things as like automatically. You don't consider things as known. You always should test. When we are using class types in Grasshopper, by default, when you're equaling, when you're referencing, when you're pouring something into something, it's actually not pouring something into something. It's actually not that we are like taking these points and pour into. So when we say PTB equals PTA, we are not basically pouring the 200, 200, 200 into PTB. What we are doing is that we are saying, hey, you remember PTA? There was a memory space with the address of, for example, 500 blah, 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 blah. Now PTB says equals to PTA. That memory space is the memory space of PTB2. So now they are both talking to one memory space, the same memory space. So this is, in general, normally, when we are talking about instances of classes, it's a by reference assignment. So we are not pouring anything to anything. We're basically referring PTA to the same memory space too. Okay, so basically what happens here is that we are we have basically in the case of the code which is not commented, we have like one memory space with whatever address, and then we have PTB and we have PTA. This address was related to PTA in the beginning when we said PTA equals this, and it has 200, 200, 200. Okay. Then when we said PTB equals PTA, like with this equal here, basically PTB also referred to this address. So when I'm saying PTA.y equals 500, says, okay, this is PTA, go to this memory address, change the y to 500. So it changes the y of this memory address. When I say write line PTB, it says, okay, go to that memory address. What is written in y is 500, print it. What happens here in this code here? In this code, I had PTA with a memory space, and I had PTB. And then when I said PTB equals PTA, in Rhino, they overloaded the operator. So basically, for these two properties, when they were defining the properties and the operators of this class, they basically said, okay, when someone equals two instances of this point 3D object, don't refer to the same memory space. Automatically run a new constructor, find the memory space, assign the new memory space to here, and take whatever value is there, copy it to my memory space. So after this, I'm an independent entity from there. It's not like back then, which we are the same entity. Now we are independent. So what happens if someone changes PTA.500? It changes this block of code, right? And when I go to PTB, this is what's referred back, right? So it doesn't matter what happens there, okay? Yes, yes. 4 points. 4 points. And actually, the point is that maybe there is a basic thing that you can remember it. I personally actually don't remember what types of Rhino are by reference and what types are by value, because it's not that I'm not daily. Right now, I'm not daily coding with Rhino. So there are times that like maybe in like 2-3 months, I'm constantly coding because I need it for what I'm doing. And then it's possible that I'm not coding even one line of code inside Rhino, or even at all, based on what I'm doing generally right now in my life, or even one line of code at all for 4 months. And then after 4 months, I totally forget. So basically, to be honest, actually, I did not remember right now whether points values in Rhino are by reference or are by value. I wrote it. I saw, oh, okay, yeah, it was by value. I remembered that it was by value, and then I started to do that. Yeah, yeah. So if you want to define a point that is referenced by value, by reference, you either should do it in Rhino by reference. There is a way for that. So, or you have to basically define your own types. But the good thing about that is that I think, if I remember correctly, this don't take my words for sure, but this is something that I remember. Maybe I remember right or wrong. I think there was a time in Rhino 6 that this point 3D was by default by reference. And every time we had to make, which was the original way of grasshopper, cSharp, which was a normal thing in cSharp. So when you wanted to make a new point, a new copy of a point, you had to make sure that you made a new instance. So what we were doing, we were overloading the constructor. So we would say, okay, PTA.copy2. So it was copying the PTA to PTB. Instead of saying PTB equals PTA, we were saying my point 3D PTB equals PTA.copy, something like that. And it was copying everything of PTA to PTB, okay? Which is a normal, yeah, and it makes another instance, which is a normal C# syntax. Uh, I'm not sure if what I'm saying is right or it was something else somewhere else, but this is something in my memory. And I think later at some point they changed it and they make it like that, because most of the cases people who were using Grasshopper, they did not have this back then. They did not have this understanding of by reference by values, and they were kind of defining like 200 points, which was actually one. It was 200 variable names, but it was 1 point. And they were trying to draw a spiral. It was not working. It was just at 1 point. And they were self-regular. So this was, I think there was some situation like that. Yeah. Mhm. This one. Mhm. Line 42, point A dot y equals to 500. Yes, it does. Okay, let me show you. So we uncomment this one, Control KU. So here the point is like it changes the point A, but we are here printing point B. So if I write console.writeLine pta.y and Control S, you see this is 200. This is 500 because because this pta is 500 and here pta is 500. Here this is 500. Yes, it makes a difference, but I want you to tell me the difference before we run the code. Yeah, because it's already changed. Yeah. Yeah, this makes perfect sense for someone with less programming knowledge. People with programming experience don't like this. That's yeah. Not necessarily 80s, even like the point is like if you are a programmer, you start to you know you need to know the class, because by default classes are by reference in programming. And when you're pouring referring them, you make sure that if you want it by value, it's by value. If you want it by reference, it's by reference. Okay. But C# allows you to change this behavior, which is a good thing, because the point is, for example, overloading the operators is very interesting because, for example, if you have 2 points in general, you could define like, okay, if I say point B minus point A, what should be the output? So in general, we can say, okay, if point B minus point A could minus all the x, y, z's from each other and give me an x point. Or I can say, hey, I want this operator to give you a vector which goes from point A to point B, which is what's happening in Rhino, which is very interesting. So because they overloaded this operator, whenever you minus 2 points, it gives you a vector. So if I want a vector from 2 points, I don't need to make a new vector from point A to point B. I just need to subtract 2 points from each other and I'll get the vector. Okay. Sometimes it's like I would say, okay, I want this, like, for example, remainder blah blah operator for 2 points, and I define, and if someone's used that remainder, for example, operator, give me the midpoint. I calculate it because I know people who are using this class are using a lot of like midpoints. So I want to make their whole process much faster and the coding much cleaner, rather than every time they say, okay, point A plus point B divided by 2, blah, blah, and then find the location. So this is a very interesting thing that adds to the quality, but at the same time, you always, whenever you deal with a class, you always have to make sure what is the behavior of the class. So don't get things as it is. Just don't imagine that you know how they behave. Always test. Or the one good thing is also like reading the documentation. So sure. If you define your own class, you can, like what we did now. No, you can. You can do a by reference as well. You can refer them together by reference. Let me check if it's like that. Yeah, no, it doesn't work like that. I should remember how does it work in Grasshopper. No, what? Ah, ah, okay. Yes, 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 yes. But we don't have some plugins. They are kind of using a sort of fake by reference system because they want to calculate based on the variables underneath. But yeah, inside Grasshopper without coding, whatever you do is by value. Yeah, and it's a copy by value. Actually, that's why it's very expensive. So in terms of computation, so it's like the, for example, like the bending component that I showed you. Uh, if you have that component, all of that inside Grasshopper, because each component allocates a lot of memory for itself, calculates a lot, defines variables, sends it to the next one. The next one takes these variables, copy that to its own memory space, and then it starts calculating, and then sends it to the next one. Then probably like the time of that component, which was like I think around a few seconds, around 1 second, 2 seconds for a whole computation, would be maybe 10 minutes just for one piece inside Grasshopper if everything was Grasshopper. So we don't have those sort of by references in many components, but there are some plugins that from what I see, I can imagine that they do by reference in the background because they have these memory units that, and for example, like they take the variables inside one of the components because they do some structural analysis. They place it somewhere in memory, and then the next component takes it from the memory and not directly from the wires of Grasshopper. And that's why those plugins are usually faster. But this is something what I guess from the behavior of the components. I never asked the developers to see what they're really doing, but I can imagine that could be one way of doing that. So, do you have any other questions? No. So, if you, yeah, 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 exactly. These are all of the details that I try to kind of gather as important information that are good for you to know when you're dealing with tools and you're actually not programmers yet, because what we reached here after like 2 days in a normal programming class that I'm teaching. I used to teach programming to people. This is not the second session. This is like after 10 sessions, but a lot of more details are there, but then you can write code. Now we are kind of doing everything in a compact way because I want to familiarize you with the concepts. So when you read code from ChatGPT or Copilot or something, you understand what's going on. So I guess you had to leave earlier, Anil, right? Okay. So I really kind of would like you to try writing a code with ChatGPT for the next time and try bring it in inside a rhino. It doesn't matter if it doesn't work, but you said you tried something. Did it work so far or not? Did you manage to finish it? Mm-hmm. Okay. Okay. So, mm-hmm. Mm-hmm. I see. And Kesra, you were also saying in the beginning that you are doing something too. You got it to work. Can you show can you show us something now or not? Yes, can you share your screen? And I can stop sharing the screen. You should be able to. Yes, yes, perfect. Mm-hmm. Mm-hmm. Okay. And did you understand the whole like grafting of the path and working with the data trees of Grasshopper or not? Okay. Okay, so one comment right now. Already, when you're writing such a code, I suggest that you already define the platform that you're using. So tell ChatGPT that what you're doing is basically inside Rhino 8 with the Grasshopper, so it knows the context. So you remember that I was talking about like the difference of .NET Core, .NET Framework, everything like that. So it knows that okay, this is the situation, and it's a newer version of C#, so it can specifically that can use the newer ways of coding. It can use .NET Core, and it should use .NET Core instead of .NET Core version 7, instead of .NET Framework version 4.6 or 7. I don't remember exactly which one. And then this way you get a more precise code. It worked now because probably there was no difference between the two, but if you don't specify the platform, there is a possibility that you get errors. Ah, Okay, so to solve this, what you should do, there are two ways. One is that, okay, you can start using the system.link. Okay, so if you go back to your grasshopper on the top, you remember there was this using part. So you can write using that system.link, and then you will get all of the link systems, which is actually very, very, very important. And you always have to import. I would always import it because this is something that is like really helpful. So if you write up here somewhere like use that using that system using space system that, oh, actually it's already used here, so why is it not working? Ah, you added this. Okay. Okay. Yeah, 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 definitely. It is possible, yeah. What I was tested, like you can tell that it is like a grasshopper, and you can tell you can tell ChatGPT. For example, what you can do, what is interesting when you're writing the code is that, and what helps a lot with debugging with ChatGPT is that when you're asking the question, you can say that, okay, this is my question. I want this inputs, and I already have this code from my grasshopper and paste the code inside the conversation. And when you paste the code, it sees the base code. It sees the base using systems, and it also sees what are the variables that you are using for input. So for example, it says that, okay, you named your input point as PT input, for example, and then you named the number of points as PT count, and you named, for example, something like that. Then it starts to incorporate those variables and those values in your code. So you basically can do everything much faster. And it also then pastes the whole code inside the code that you provided as a base uh, uh, pattern for the code. So this whole thing is also resolved. And whenever you see like this situation that something is used or not, then you can actually start complaining to it and say that, okay, hey, this there is a function you're using and it doesn't work, and I get an error. And the best thing is that if you really read the error from Rhino and write down there, so you say this is the error code, this is the exception, and this is what Rhino or Grasshopper or Visual Studio complains about. And if you do that very explicitly and properly, then usually you get a proper answer.